Welcome to AI Frontiers, where we explore the cutting-edge research reshaping artificial intelligence. Today we're diving into 17 groundbreaking papers, published on October 23, 2025, all from the computer science artificial intelligence domain. These aren't just academic exercises. They're blueprints for AI systems that will transform how we work, think, and solve complex problems through collaborative intelligence and multi-agent systems. Picture this. You're sitting in a doctor's office, and the physician pulls up your medical records on a computer screen. Behind the scenes, an AI system is quietly parsing through thousands of medication entries from different hospitals, clinics, and pharmacies you've visited over the years, each using completely different computer systems and formats. Within seconds, it creates a complete picture of your medication history with 93% accuracy, better than most human medical assistants could achieve. This isn't science fiction. It's happening right now in healthcare systems across the country, thanks to breakthrough research in collaborative AI agents. Think of the field of computer science artificial intelligence as a vast construction site where engineers are building the cognitive architecture of tomorrow. These 17 papers, published on October 23, 2025, represent the Master Blueprint Department, the place where researchers figure out how to create computational systems that can think, reason, and make decisions like humans, but at unprecedented scale and speed. It's the bridge between the abstract concept of intelligence and the concrete reality of silicon chips and algorithms. These discoveries don't just advance our technical understanding. They're reshaping how we approach human-AI collaboration. What makes this field particularly fascinating is its interdisciplinary DNA. Computer scientists here don't work in isolation. They're constantly borrowing insights from psychology to understand how humans think, from neuroscience to model brain processes, from philosophy to grapple with questions about consciousness and reasoning, and from mathematics to build the formal foundations that make it all work. It's like watching master craftsmen from different trades collaborate on building a cathedral, each bringing unique skills, but all working towards something greater than the sum of its parts. The first major theme emerging from this research is multi-agent systems and collaborative intelligence. Imagine trying to plan a wedding by yourself versus having a team of specialists, a caterer, a florist, a photographer, and a coordinator, all working together. That's the difference between traditional single-agent AI systems and the collaborative approaches researchers are now developing. The spatial text-to-SQL framework by Kazazi and colleagues exemplifies this perfectly, using specialized AI agents for different aspects of translating natural language into database queries. This collaborative approach achieved 87.7% accuracy compared to 76.7% without the review agent, a remarkable 11 percentage point improvement from teamwork alone. The second prominent theme focuses on evaluation and benchmarking of AI systems. As AI capabilities explode, we desperately need better ways to measure progress. It's like trying to evaluate athletes. You can't just time their 100-meter dash and assume that tells you everything about their overall athletic ability. Researchers are developing comprehensive benchmarks that test different aspects of AI intelligence, from geometric reasoning to real-world e-commerce interactions. One particularly intriguing development is a coherence-based measure for artificial general intelligence that reveals current leading AI systems like GPT-5 achieve only 24% on this more stringent metric, despite high scores on traditional evaluations. Our third significant theme involves specialized domain applications. Rather than chasing the holy grail of general-purpose AI, many researchers are focusing on creating AI systems that excel in specific domains where they can provide immediate, measurable value. We see this in healthcare systems that extract medication information from electronic health records, in e-commerce platforms that handle customer queries across multiple languages, and in power grid optimization systems that balance supply and demand in real time. These domain-specific applications often achieve remarkable performance precisely because they can be tailored to the unique challenges and requirements of their target environments. Now, let's examine our first key breakthrough, the spatial query revolution. Picture yourself as an urban planner trying to find all the parks within walking distance of schools in a specific neighborhood. Traditionally, you'd need to know complex database query languages and understand geographic information systems. Now, you can simply ask in natural language, "Show me all parks within 500 meters of elementary schools in downtown." The Kazazi research team's multi-agent system breaks this down into subtasks, identifying what parks and elementary schools mean in the database, understanding the spatial relationship within 500 meters, and generating the precise SQL code to execute the query. Their collaborative approach achieved 87.7% accuracy, making spatial data analysis accessible to non-experts for the first time. For our paper of the day, let's examine From Questions to Queries, an AI-powered multi-agent framework for spatial text-to-SQL by Kazazi and colleagues. This research tackles one of the most challenging problems in database interaction, translating natural language questions into spatial SQL queries that can extract geographic information from databases. Picture yourself as a city emergency response coordinator during a natural disaster. You need to quickly identify all hospitals within 10 kilometers of the affected area, find evacuation centers that can accommodate at least 500 people, and locate all major transportation routes that might be blocked. The research team recognized that previous attempts using single AI agents consistently failed because the task is simply too complex for one system to handle effectively. Their solution was elegantly simple in concept, but sophisticated in execution. Create a team of specialized AI agents, each focused on one aspect of the translation process. The first agent, the Entity Extraction Specialist, identifies relevant database entities from natural language questions. When you ask about hospitals near the downtown area, this agent recognizes that hospitals and downtown area are entities that need to be matched to specific database tables and columns. The second agent, the Metadata Retrieval Specialist, gathers contextual information about database schemas and relationships. The third agent, the Query Logic Formulation Specialist, develops the logical structure of the required query. The fourth agent, the SQL Generation Specialists, translates this logic into executable SQL code, handling the complex syntax of geospatial functions. Finally, a review agent performs both programmatic and semantic validation of the generated SQL. The results speak for themselves and demonstrate profound human impact. On the non-spatial Kaggle DB-QA benchmark, the system achieved 81.2% accuracy after review agent corrections. More impressively, for spatial queries on their custom spatial query QA benchmark, the system achieved 87.7% accuracy compared to 76.7% without the review agent. What makes this research particularly compelling is its democratization effect. Urban planners without SQL expertise can now query traffic patterns, environmental scientists can analyze pollution data, and business analysts can examine customer geographic distributions. The framework makes spatial data analysis accessible to non-experts while revealing that intelligence might be inherently collaborative rather than individual. Looking toward the future, the research landscape in computer science and artificial intelligence resembles a vast ocean with multiple currents converging toward new territories of possibility. The first major direction involves the continued evolution of multi-agent systems toward more sophisticated forms of AI collaboration. Think of this as moving from individual musicians to jazz ensembles to full orchestras. Each level of collaboration enables more complex and nuanced performances. Future AI systems will likely involve dozens or even hundreds of specialized agents working together on complex problems, with sophisticated coordination mechanisms that allow them to share knowledge, divide labor efficiently, and learn from each other's successes and failures. The second direction focuses on bridging the gap between specialized AI systems and general intelligence, requiring fundamental architectural innovations rather than simply scaling up existing approaches. As we wrap up today's exploration of the AI research frontier, we've journeyed through 17 groundbreaking papers that reveal both the remarkable progress and the exciting challenges ahead in artificial intelligence. We've seen how collaborative AI agents can democratize access to complex spatial databases, how new evaluation metrics reveal the limitations of current AI systems, and how open-source models are achieving clinical-grade performance in healthcare applications. The researchers behind these papers aren't just advancing technology, they're grappling with fundamental questions about intelligence, collaboration, trust, and the future of human-AI interaction. Their work demonstrates that the field of AI has matured beyond simple performance improvements to address the complex realities of deploying intelligent systems in the real world, pointing toward a future where AI is collaborative, interpretable, and human-centered. This synthesis was created using GPT Anthropic CLAUDE-SONNET-4-202505114 for research analysis. With TTS synthesis powered by Deepgram technology and image generation utilizing OpenAI systems, the content underwent human expert review process to ensure accuracy and accessibility. We acknowledge that potential oversights may exist, and full references to the original research papers are provided for verification. This transparent approach ensures you understand both the capabilities and limitations of AI-generated research analysis while maintaining the highest standards of academic integrity. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Subscribe to AI Frontiers for cutting-edge research insights, with weekly deep dives into breakthrough AI papers, expert analysis of trends shaping artificial intelligence, and community discussions on the future of human-AI collaboration. Be part of the conversation defining tomorrow's technology. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org content under its AI terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.